கேட்க ஆனவனான்னு பண்ணலாம் பேட்டரி வீணா போகும்.
ఏదే ఉమ్, ఇదో.
ఇది నేను నామకం
Hello guys, good evening. Hope you're audible. Is
Yes, sir.
any yes on your chat box? Yes, thank you. Good
Yes,
evening.
sir.
Now,
Let
Yes,
me
sir.
share my
now it's
screen.
audible.
Okay, fine. So yes, happy to see you all after a long period after your exams. Today we'll be moving towards your machine learning. So what is machine learning? Where your machine learning is going to get into. So machine learning is not a bit of your complexity that only your people could able to learn, who is learning the computer science only want to learn your coding part. So it's not about that. So anyone able to do it right now, we have an our AI tools like Google Colab or else ChatGPT or Gen AI like ChatGPT or else your Profi. We have all the AIs to work on with the machine learning coding part. So machine learning is not nothing much bit about your coding part. It's all about your analysis to have much more accuracy when you have your lack of data or too lack of data. It could not you could not able to load it on your SPSS like analytics tools like SPSS or else your Excel. You could not able to load it. So you could able to load only a certain amount data even you could able to put up your data like 1,34,000 data you could able to load it on your Excel, but still it will take more time to computational time. Depends upon your system how much GB of your RAM or your processor you are holding up. It takes so much of time according to that. But machine learning makes you for a simpler learning, like you are going to run up the code, like you are going to upload all your libraries, upload your data set, then you whatever you wanted, you are just going to ask with Gemini AI or else your chat GPT for the code, and else you are going to, as of now, we are just going to look after the analytical parts. So coding part comes next, as when you are going on with the core computer science or else when you wanted to go ahead with the learning coding, that's absolutely fine. But as of the time being period, we just looking much more deeply onto analytical part, or else after you reach your result, how to interpret your result. That's what we are going to concentrate much more on the session. So right now we are moving to what is ML. So as you see here, ML is a subset of AI, whereas artificial intelligence then comes, it's a part of ML is your part of your artificial intelligence. Then comes your deep learning. What deep learning means to be like, for machine learning you could able to post some more data like image processing or else your face recognition. You could able to put it on your machine learning as well, but that takes much more computational part compared to deep learning. So that right now, that's a subset of machine learning. Deep learning is a subset of machine learning, where you'll be having in between, you'll be having a much more layers like input. You'll be giving an input of, say, for an example, I want to sum a number of five numbers, like say for an example, 1, 2, 3, 4, 5. I'm having a five numbers, you are going to get the sum out of it. But in between to that, right now, I'm having a smaller size of the data. You could able to do it with your calculator or else with your SPSS or with even with Excel. But when it comes to like 1,000 data, 2,000 data, you could not able to keep on calculating with the calculator. So that's why you are moving with the SPSS or with the Excel. When it right now when it comes to 1 lakh data, 2 lakh data, I'm going to use my machine learning. When it comes to like 10 lakh, 15 lakh data, like I need to analyze my whole summary of last 15 years of temperature. For each and every minute my temperature is getting changed on a particular region, right? So right now it is as of Indian time, it is 8:42 p.m. Right now I'm going to have a temperature. So the time goes off like 10 o'clock or 11 o'clock in the night, my temperature is going to get down. So automatically, same like your mobile phones. whenever you open your Google or whenever you open your mobile, you'll be having a climate prediction. So when you click on to that, it says that for the next 2 to 3 days, what would be your prediction of climate data. So same like this, how that prediction is going on with that is you are going to the system on the back end. It yes, Mufis, any clarifications on large, complex, and high dimensional data set? No worries. Go ahead with the scribbling. It's all your PPT. You can do whatever you want. You have all the freedoms to be done. So coming back to the point, whenever we are moving with the prediction part, so like I need to go ahead with the prediction for the next 2 to 3 days. Obviously, I need to have a historical data, like my previous data set of at least for 5 years of time. So that's how when I'm going to have a part of the next 2 to 3 days of my prediction. So when it comes to deep learning, it handles with your 10 lakh or 20 lakh data, or else your big data analytics comes into the scenario, or else your image processing, your face recognition, your whatever you do whenever you open your mobile, whether you use an iPhone or an Android phone, whether whenever you open, it acts on 0.3 seconds to open your mobile phone. Whenever it recognizes your face, it unlocks. So how that computational part of 0.3? Maybe now in between we had an issue of there is a fingerprint issues on the particular mobile brand mobile. I don't want to explicit much on brand. So I whenever I keep my finger onto the fingerprint, it takes much more time to open compared to other mobiles, any other mobiles. So this also a computational part, whereas it is having onto your back end whether how much computational part or validation part that should be acting upon to you. So then comes only your part right now, whatever you're using your chat GPT or proxy A, whatever the A right now, you are using Gemini A or else your Bixby, iOS, Kavala, Siri, whatever is you are using it right now, it is all your generative AI. So this all comes later to that as subset only. So before to that, we have to understand what is machine learning, how does it acts. Then only we could able to understand the generative. As of today's session, we'll just look upon only of the machine learning process. If you want next class, we'll be looking much more deeper onto deep learning as well. So deep learning has your input layer and your output layer. In between, there are many of the layers to get into computational. Again, when you are getting an output, like say for an example, you are getting for three data, 1, 2, 3. I'm going to have an output as 6. Everyone we knows it. 1 plus 2 plus 3 equal to 6. But in between, there are many of the layers where it is an summation, where you do with a mean value, median value, mode value. It's all in between as a hidden layer. Again, what deep learning does is that with this 6, I'm going to have an backend as well. From output, it is going to give you a computational part from backend. It is called as backward propagation. So it will verify that whether this 6 is going to have this 3 plus 2 plus 1, am I going to have this value. So this is what deep learning is much more accurate, but that takes, as said earlier, that takes an much more computational time, depends upon your systems, your processor, whatever you use. So right now, when it comes to machine learning, this is what this diagram represents of AI, ML, DL, and your Gen AI. So the learning process involves training data set, test data set, and validations of the model. So these are the data pre-processing steps. Right now, we'll be looking on to the training, testing, and validations of models, how we are going to do ahead with that. So right now, as of today's session, we are going to handle with the large complex sessions, which have many other variables, maybe like one dependent variable and many other one independent variable. That would be easy for you to compute it with the SPSS. But when you have like 61 independent variables, or else what is your class performance? I need to go ahead with your whether you are scoring 70 marks in your exam or 60 marks in your exam. How on which parametrics, on which metrics am I going to measure that? Your class attendance, your class participation, your how much you are interactive towards the session. So these all my independent variables which comes into my scenario. So whereas my dependent variable will be like my output. What output am I going to get is your dependent variable. So for throughout the session, we'll be having a conversation like dependent variable and independent variable, maybe like DV and IV. So DV is mainly what output you wanted to earn will be your dependent variable, and what all the parametrics you have in between will be so called your independent variables. So this is widely used for your prediction, mainly based for your whenever you are doing your financial analytics for stock market trading. You obviously wanted to have your prediction, even as said earlier, your uh, mobile your mobile climate will have a prediction. So mobile climate or your weather have your predictions. So classifications is nothing but whether it's a male or female, how many male I have, how many female I have, or else I'll explain you on the later, like clustering decision making problems. So this is what your drag it down. So here is what your general descriptions like how data science, AI, ML, and DL is going to differ on each other. So data science is generally button when you have the three data like 1, 2, 3. We'll have as of now common we'll have a common data like 1, 2, 3. We'll have a common data like 1, 2, 3. So that I'm just going to have a bar chart or pie chart. A pie chart generally looks upon when it comes to a ratio scale. You'll prefer bar chart when it comes to a normal 1, 2, 3 normal ranking scales or your descriptive statistics. It comes to your bar chart. So AI it includes an ML, but ML is a subset of AI, whereas as I said earlier, DL is also a subset of ML. So this is just for your theoretical part to be concluded. If you have any clarifications, you can just go through on to that. And when it comes to machine learning, we always looks upon three things. Right now, we have taken only two things, which is called as unsupervised learning, unsupervised learning. Whereas your third thing will be called as an reinforcement learning, where reinforcement learning will be requiring an supercomputers or else and your agents are there to help you out to deal with a large number of data set. As I'm working with the data set on airline related. So for an India or else worldwide, if an airline is operating, you could not able to collect a data set for all the airline, whatever is operating from Mumbai or else from Bangalore or else from Delhi. You can collect the whole data set. You'll be having an n number of data set out of which for a particular day. Only for a particular day, there'll be like 27 routes for a particular station. Whereas from stations to station, it differs. So reinforcement learning, we are not going to much involve much on reinforcement learning. Right now, we'll be look upon with the supervised learning and the unsupervised learning. So supervised learning or nothing, but what is the only one difference is that supervised learning are the labeled data, whereas the unsupervised learning are your unlabeled data. So supervised learning, I have my labeled data, whereas my target is unknown. Whereas for the unsupervised learning, I don't have my predefined outputs that this should be my output or else I'm going to target on this because for the labeled data is nothing but if in the case of like gender, you'll be having on the top like gender, you'll be having like male, female, or prefer not to say or else no comments on concluding on your gender. It's all comes upon your labeling. Whatever you are the questionnaire you have collected, it's on your labeling. Whether how much you like my class is you have the 5 scale rating. So you have the label data on the top, like how much you like it. When it comes to unsupervised learning, it's like just like you are having the hidden patterns. Same like your stocks. your stock doesn't have your label data. You won't have the top, only one label you'll be having is that for the particular company, for the particular time period, you have that particular data set. That is what will be given to you. There won't be any of the labels that uh, regarding your data set. So you are just going to analyze what is the hidden patterns, what would be the next result out of it. So the people who are investing on stocks or else who are working on the trades will always know about it. So right now the company is getting down. I'm going to buy the stock right now so that on the next 4 to 5 months of time, the company is always going to get higher. How much sure are you going, are you aware that the company is going to get higher onto that? That's what your prediction means to be. You are analyzing the previous year balance sheets with respect to your hidden patterns or else your structures, whatever has happened. So right now, for this concern, we'll be looking ahead with when it comes to your supervised learning, we'll be looking ahead with the regression. Regression, I'll explain you all the three regressions: linear, multiple regression, and your logistic regression comes here. And your decision trees, support vector mission. So that on supervised learning, I'll be covering the three topics on regression, uh, de- uh, decision trees, and your support vector machines. When it comes to your unsupervised learning, I'll be going ahead with k-means clustering and hierarchical clustering. So how much it is going to get classified according based upon your data. So as said earlier, data pre-processing and preparation is nothing but data collection, data cleaning, data integration, transformation, feature engineering, data reduction, and data splitting. So you have the 7 types right now here. These are all the mandatory basic steps to be followed now. So let me come back one by one. So data collection is nothing but you are collecting your data, whether it might be your primary data or secondary data. When it comes to your secondary data, that might be your text mining. You could able to collect your data using your text mining or else your web mining. Whatsoever the data you require, that could be of qualitative or quantitative, no matter what, it all comes under your data collection. So data cleaning is nothing but all is a data set will contains a manipulation of data or else misleading data which could able to change your value to the top more. Like you will be having a data set of 1 2 3, and suddenly your data on an misentering of data, it would go for the next data would be of your 97, so that your total your value changes get difference. So that 97 will become your outlier. So that data cleaning will take care of that. Your missing values, it has your missing values, that means your none values it has. So it always reduces, you could not able to, when it put on your Excel sheet, you could not able to manually check onto 1 lakh data whether all the data, all the columns and rows has the particular data available over there. But when it comes to machine learning, when you put the single code like remove all the none values, it removes all the none values and represents you how many rows and columns you have the data set along with you. So data integration, and when it comes to data transformation, you are going to select about what are the things you require, which features can be like which variable can be ignored for my study. For example, you'll be having an for when it comes to descriptive, your name, gender, your qualification, your location, your annual income, it all comes on your descriptive. That is all mandatory thing that could not be neglected on any way. When it comes more than to that, you could able to remove that whatever you wanted to study. Getting back to the same example as I said, whether you wanted I need to know 70 percentage you are getting, you wanted to, I wanted you people to get in 70 percentage marks on this exam. So what are the parametrics I'm going to have? Someone will have a parametric of gaming addiction. Yes, gaming addiction is also plays an important role, but still that is not, gaming addiction is not important to me when it comes to my performance level. Feature engineering, which feature has to be chosen depends upon you. Like whether SVM, whether you are going to do your classification test or your regression test, you wanted to predict your future, or else you just wanted to split the two data set, whereas I wanted to know how much male and female are there, how much it is being clustered. So I need to carefully be chosen on this feature engineering. When it comes to data reduction, as the word says, the data reduction, you are about to reduce the data set depends upon how many sample you need really. So there are samples which are known, which are unknown samples are also there when you are collecting about the data. Data splitting. You have two types of data, which is of trained data and test data set. So one is of trained data set, either you could able to 70-30 percentage or else 80-20 or 95-5 also you could able to give. That is up to you. So 95 percentage, I'm going to train my data set with the previous historic data available. For example, when we come up to our temperature thing, so I haven't passed history of 10 days data. I just need what the temperature would be for the next hour. I'm just going to have for only for 1 hour, whereas I have for several hours of data I have along with me. So that I'm going to train all the 95% of data, and for the 5%, I'm going to have a test result so that when it acts accordingly, you'll be having a prediction of the next thing. So this is where it comes to your data splitting. Linear regression is right now we are getting back to your supervised learning methods, your regression techniques. Always your regression is that, just give me a minute. So could you please could anyone respond that my pointer has been visible? My laser pointer is visible.
Yes, sir.
Yes, sir, visible.
Yes, visible.
Yes. So these points are all my data set where I have right now with me. So this is my best fitting line, whereas my regression line says that for this is what the regression line means to be like. I'm having this regression line mathematically. If you're going behind, it is like y equal to a plus bx or as y equal to mx plus c. That depends upon physics when it comes to maths or else when it comes to operations, when it comes to ML. So it all depends. Anyhow, that is all background is all going to be the getting the same. When I have one dependent variable and one independent variable, I'm going to have the data set of x and y for x as independent variable and y as in dependent variable. So this would be my line of regression. This acts as my y equal to a plus bx. So nothing much on don't get into like simpler a plus b whole square formula. So don't nothing much to be complicated much on that. So y, as I said, y is a different variable. So a is your point of intercept. Your a will always not be a zero. This point won't touch this point. It won't be starting from your origin, or else your a won't start from your minus. Whether here or -1 or -2, it won't start from minus. So always your intercept won't start from your 0 comma 0 value. It always moves away from the value. This is not necessary to be like this. You could able to have from here as a regression line or else from here as a regression line. That depends upon you. That depends upon the data set you are collecting. Whether when it is directly proportional, you could have it from lower to higher. When your data set is directly proportional, your dependent variable are directly proportional to independent variable, you'll be having the line like this. And if not inversely proportional, like my sales depends upon my advertisement. Obviously, when I give more advertisement, I'll be having a more sales. So same like that, you'll be having for an independent, sorry, inverse relationship also. That time you'll be having a regression line from top to bottom at a cross version. So these are my data set, and one second, just a minute. So this is what my value is called as an residuals from this is what this line is actually a predicted line where I'm going to have it for the future of references. But the point which is moving away from the actual predicted line is called as your residuals. This is all your residuals distance. This residual distance can be calculated using your Euclidean distance. What is the distance between actual and predicted? So this is what my actual line, and this is what my predicted line goes with. So what is the distance between? So there you might have a data set in between also, so that could be acted as your outlier data set. So right now, as of now, I have for only for this data set, I'm extending for the further. So if in the case of future, my data set is always going to have on these places. My data set either will have on this place, either this place, but not over here or over here. So when it follows a line, obviously my future is also going to be get predicted along with this line. When it comes to a logistic regression, it always deals with your categorical things, whether it is yes or no, whether it is true or false, or 0 or 1, whether it is male or female. You could able to change that categorize into I want to have that male as 1, female as 0, or as male as 1 and female as 2. I could able to go ahead with that. And right now we have a date. This is what your output looks like. So this is your confusion matrix, which states your actual versus predicted. As said earlier, we'll be discussing on this linear regression. We'll be discussing on with the data points. But right now, I'm going to have only with the two variables, whether it is yes or no, or true or false, or whether it is a. I have, as of this output, I have input my data. My previous historical data lies like it is a dog. I'm giving a, 1000 number of data where it states that whether it might be different hybrids like Pomeranian or Bulldog or a Rottweiler. I'm going to have a statement that whether it is a dog, it is a dog. I'm going to train my model as this is a dog. This is what dog looks like. So suddenly, in between of my data set, I have a data set of cat. So obviously, cat and dog looks the same tail, same ears, same mustache, everything going to be same. But my machine learning wants me to get included about that. So that I want my model to state that whether the cat, whether it is going to predict my cat as cat or else dog. So I'm going to test my data set. So right now I have the dog. This is actual versus predicted. So actual, when it comes dog and dog, it says that out of 5 data set I have included, it all says that it's a dog. One might not look like a dog. That might be a puppy or else like a dog, like a cat, or else which looks similar to the dog. So when it comes to this is not your dog. That is a predicted value. I have a predicted value over here. It is predicted that one of your image out of 5, one of your image might not be a dog. This is what it states. So same thing comes here. This is all as is a collinear. So we are just moving at the same 1 and 1. So not a dog, not a dog. When it comes here on the x-axis and the y-axis as well, both the things has the thing. It's not a dog. So it's just a predicted value that I have 3 not dogs actual with me. So this is what your logistic regression output looks like. This is a confusion matrix. Maybe you could able to take it with your ROC curve or else your prediction. Predictions directly gives you the value that 99.8% or as 92%. It has the actual versus predicted. It has a good accuracy. When you are coming back to decision tree, same like in our school days, we could have done with our decision tree. Whether you wanted to go to school, yes, no. If in the case of yes, why I'm going to school? Yes, I'm going to school just because for my friends, just because they teach me good. If I'm going to the school for my friends, how Josh am I going to be? Or else I have good friends towards with me. If I'm going for the teaching, so this is what your general decision tree looks like. So a guy goes to an interview. So after going for an interview, he's on to the borderline stating like for an example, you have the 40% of your pass mark in your interview. You want your 40% of your pass mark in your interview. The candidate was, unfortunately, he lies on to the between like 38 or 42. He was just to pass or just fail. So was the candidate rated as borderline candidate? Yes, you have the only two options like yes or no. Did the raters agree on this decision? So whom were the panel members? Raters agree on this decision, like whether this marks could be like 42 marks could be depend upon his 12th grade marks or else 10th grade marks or else your interview performance as well. If the raters agree the question, yes or no. If in the case of yes, take the agreed decision, remove him out of the company. If not in the case no, then you have to question back to the raters. Are the raters are going to be like a equally experienced one? If not in the case, yes, take the most confident decisions. If not, no, take the senior decisions. Like you have to go back to the same thing. Again, the process comes back. So this is what your decision tree comes into scenario. So this is what your root node called as. Your first ever node will be of your root node. So these all your internal nodes, whether did the rater agrees on the decision or your uh, are both the raters equally experienced. This is of your internal nodes and branches. What are the outcomes you are going to come? Like take the agreed decision, determine the random. Your leaf nodes. What is the leaf node? Final decision, whatever you are taking out of the conversation, that comes your leaf node. So this is actually when it comes to your qualitative part, like which only deals with yes or no. When it comes to your quantitative part, it deals with the numbers. So that whenever you goes with X or no, you will be having a proposition of 70-30, or else when it is no gets higher, you'll be having a proportion of 80 and 20 over there. So you'll be having an probability of both the nodes, whatever you're getting. Maybe you can have another node of maybe you are right now we are having S here, no here, and for the third node you might have the prefer not to say or maybe. So you might have it. It is not necessary to have only two nodes. You can have n number of nodes depending upon your decision, whatever you are going to get upon. So fourth is support vector mission. Support vector mission is nothing but the same like your regression line, but only different what it does is that it is going to separate both of the lines. Like uh, I have a red, for an example. Right now we have an red dotted line over here. As I said in the previous regression slide, it is not necessarily need to be like from left to top. It is always can be like top to bottom as well. This is one of such an example on that. So I'm going to split my data set. This is for my classification part for the labeled one. Labeled data set classification part. For claiming, next comes your k-means clustering. I'll explain you that. I don't want to confuse it because there is a similar minute difference between this both SVM and your k-means clustering. So I'm going to segregate your male data and your female data here. So with this, I'm having the midline which segregates. It is not your best fit line. Regression line is somewhat called as your best fit line for your future prediction. This is the line. Your hyperplane only divides both of your data set for your categorization. That when it comes to your one dependent variable and one independent variable, we are just having the 2D plane. When it comes to two or more data set, you'll be having a two or more independent variable. You'll be going ahead with the Z plane, another with the Z plane. So you'll be having on a 3D dimension as well. So this is what your hyperplane. Hyperplane is going to segregate both of your data from here and there. That leads not to be like your outlier data. Suppose any one of your data, any one of your male could resemble like your female, or else a female could resemble like a male. So at one data, any one of the data will go out of here and acts according to them. whenever your twin opens, if you have a twin, if your twin opens your mobile, automatically gets open. But it's not you. That should not happen actually. As of you, you are the owner of the mobile, and whenever you are opening, because nowadays our mobile becomes a privacy for us. It becomes a privacy that even a brother should not open, or else mom should not, parents should not open. We have came to that scenario. So for us, privacy matters. So my twin brother looks like me, but for me, as of my concern, whenever I'm opening my mobile, only the owner, if the owner opens the mobile, that should get open. It is a major lack that whenever my twin brother is going to open my mobile, it is getting open. It is your outlier or your malfunction of your data set, whatever you have. So when a girl looks a boy, when a girl
ఇవన్నీ ఫుల్
does a haircut,
అనలాగాను సత్యానది.
when a girl does a haircut, like a boy cut, or else whenever a boy grows a hair, it will be like it will be it can be considered as a male or else either to the female level as well. So that is called as your outlier. We have the separate models to pull your outliers from here to over there when it lies on the right side. So right now, so far we have completed our supervised learning methods. Now we are getting back to our unsupervised learning methods, where you won't be having the labels on the top. It will be on your um, like stock data or else your temperature data. It won't have any of your labels on the top. So when it comes, you will be having the mid value. So this is all your value will be of a normal data set, like this as simple as scatter plot, like same like box plot, or else your pie charts. This just your scatter plot. You are going to segregate out of it in the between, and you are going to have a mid region. This is called as a centroid. For the three regions, you are going to have a centroid. You'll be fixing that centroid randomly. You might fix this centroid over here as well. You could not able to know that whether that centroid is going to represent all the data set which is all along. So again, you are going to have it. You are going to run a test. You will find that whether it is a proper centroid, and you are going to segregate it out. And if the centroid is not proper, again you are going to randomly put your centroid to the next portion, and then you are going to segregate as a 3 clusters. You can have a n number of clusters, like a maximum. It will be so clumsy if you have like 4 to 5 clusters, more than 4 to 5 clusters. So principal component analysis is nothing but you could have done with your factor analysis method. I'm having right now, I'm having a 10 independent variables right now with me. Same like getting back to the same example, performance level. I'm going to measure your performance level or else uh, your sales at your company. You wanted to measure the sales at your company. So you have the n number of parametrics write down. As I said, a model reduction, a data reduction. This is also same like dimensionality reduction. You are just going to reduce your feature, whatever you are choosing it right now. So like when it comes to PCA, you'll be having the V term called as VIF. It is variance inflation factor. It is called as an VIF. It states that what are the values most likely to contribute for your dependent variable. Whether my advertisement is going to contribute much on sales or your employees participation, employees performance, or else your clients satisfaction, which is going to have the much more reliability towards an output, which is called as an your sales. It's all your parameters. Wherever they have the least priority, we will remove that particular parameter. If it is there in the data set, no issues. If it is not there in the data set also, it is not going to change my value. It is not going to contribute much for my output data set. So here right now for PCA will be PCA and factor analysis will be the same. Factor analysis will be going ahead with the clustering or grouping your variables depends upon your clusters. When it comes to PCA, you are just reducing your parameters whichever you wanted actually for the study. So hope I'm clear on supervised learning and unsupervised learning. This is what basic steps. So coding part is separate out of it. So just wanted to enlighten you regarding the theoretical part out of it. And any queries or any other clarifications as of now? Or any other suggestions to be said to me? Any clarifications can be asked or said at the moment. I could able to explain it much more simpler way how you could able to understand it, because as of now this was the basic terminology whatever I have done. This is a basic whether if I wanted to go ahead with the sales or else with the academic related or with any other terminologies what you want, I could able to give an example much more precisely onto that. Yes, anything can be posted on the chat box as well. Always ready to welcome. Yes. One thing, hope everyone understood. Oh, what is machine learning? Because I joined late. Okay, fine. Okay, Mohammed. So machine learning is nothing but your subset of your artificial intelligence. So deep learning is your subset of machine learning, and generative AI comes next with the next deep learning subset. So machine learning, why machine learning you do require a machine learning is that we could able to do the same computational part using your SPSS or else your R software or with your Excel. Normally, we don't want to go ahead much with SPSS or else R Python. I don't want to go much. Let's have it on a simple way that you wanted to do some computational using your Excel, like maybe like the data set of 1, 2, 3, 4, 5. You have the 5 data set. You are going to do ahead. For me it would be fine, I'm using my calculator, or else when it comes to Excel you could able to do that equal to sum of so and so from A1 to A5. I'm doing that, that's fine. But why I need to use the machine learning is that I might have plenty number of data, n number of data, which includes your 1 lakh or 2 lakh data. That time I cannot able to measure which data goes as an outlier. Like what outlier means is that you have all the average of your marks lies upon your 40 to 45. You are scoring 40 to 45 on a test, but suddenly a guy takes like 97, 98. That becomes an outlier. That is going to abrupt all your entire average value. So that's the reason we are using machine learning in order to remove the mid values, like missing values or else your which the value which goes to the extreme higher. So machine learning does that. For the computational easiness, we will use the machine learning as well. Because when you're loading your 1 lakh data or 2 lakh data into your Excel, it takes a lots of time. One second. I'll get back to you, Sabresan. I'll just so that's the reason we are using ML. You can use ML in your Python or else your Spider, Jupyter software, whatever it is. Just you are not going to upload all the data set. You are just going to copy your path so that it will be easy for the computational process as well. Not like Excel. Hope you got it, Mohammed. Yes, Sabresan. Sabresan has a doubt on what is a negative margin, a negative hyperplane and positive hyperplane.
Mar.
Yes. Yes, Tarakilano. Yes, how may I help you? Whomsoever has spoken, how may I help you? Yes. Thanks for muting once again. So Sabresan, right now we have the maximum marginal plane, whereas I'm not going to have the data more than this place. So positive hyperplane is that I'm not going to have this particular data less than to this. Might be I might have this positive hyperplane lesser than to this level and not like that, or else to this level as well. So it is just a positive hyperplane and negative hyperplane segregates the gap between your hyperplane and your data points which is available. Negative hyperplanes comes into a scenario when you have the negative correlation. Yes. Separation, hope you got it. Probably. Yes, no. Yes. Thank you. It's just a point that segregates the data set and your mid hyperplane. That's it. Is anything else? 38 people, 38 participants are there, including me. Sorry, ignore me. 37 are there. One thing everyone would have understood, or else just switched on and you left. So, with the no clarifications or any other doubts onto this, we'll just wrap up the session. Thank you. Thank you, Sanesh.
Thanks.
Thank you.
Thank you, sir.
Thank you. Thank you. Thanks for everyone.
Thank you, sir.